This is a video on graphing the absolute value function. So we're going to have a table of values down here just to graph this for the first time. So when we plug in 0 into our x, we get the absolute value of 0. Now absolute value is how far something is away from 0, and 0 is 0 away from 0. And together this makes our point 0, 0. When I plug in 1, 1 is 1 away from 0, so I get the point 1, 1. 2, when I plug in 2, I get out 2. So as I start to figure this out, I'm plotting points. Now, as I have been graphing lines in this whole unit, I get the sense that this is a linear function. And the common mistake is to just graph this as a line. But no, that's not how it works. Because the second I plug in -1, thinking about this on a number line, here's 0, here's -1. How far is that? It has a distance of 1. So -1 gives me 1, and -2 gives me 2. So what happens is I don't end up getting any negative numbers. So I have kind of a partial linear function on each side, and it ends up looking like a V, and that would be the absolute value of x. Now what happens if I were to change the equation ever so slightly, like 2 times the absolute value of x? So if that were the case, I don't have to do all of the points. I can just show you for a couple of points. So if I were to plug in -1, I'm going to do 2 times the absolute value of -1, which is 2 times 1, which gives me 2. So if I plugged in 1, I would get out 2. 0 would give me 0. And then 1 would give me 2. So what I have is a very similar graph, except it ends up being a little steeper. So I have 0, 0, I have 1, 2, I have -1, 2, and I get a steeper V. What if it were y equals -1/3 times the absolute value of x? I'm going to plug in some different numbers for this one. I'm definitely going to plug in 0. The absolute value of 0 is 0, times -1/3 is 0. I'm going to plug in -3 and +3 just because it's going to make the values a little bit easier to work with. The absolute value of a -3 is 3, times -1/3 is -1. The absolute value of 3 is 3, times -1/3 is -1. So in this problem, or this equation, I don't really have a lot of room over there. I'll graph it below. Two things are happening. I have 0, 0. I have -3, -1, and I have +3, -1. So it has done a couple different things here. It has gotten much wider or shorter, and it's also flipped over the x-axis. So basically, what I like to do is I like to look at the slope of each of the branches. So we have a slope of 1 here and -1 here, and that's when it's just plain old absolute value of x. For the second one we looked at, that 2 will kind of translate into a slope of 2 on the right and a slope of -2 on the left. And then for the third graph, it would give us a slope of -1/3 on the right and +1/3 on the left. So it really just affects the slope of each side. And that's graphing absolute values where there is a scale change.